Hi everyone, how are we doing? I hope we're well. Lovely to have you all in chat already. It's exciting. We've got a really cool masterclass today. I'm excited to learn. I know very little about Unity and coding and not coding, so I'll be here listening and learning and taking notes as well. um, Hopefully the sound's okay. If it's not, please let me know, and I can try and troubleshoot as we go. But I wanted to welcome the wonderful Thomas Winkley from Unity to the stream today, who's also in chat, who's going to be delivering today's masterclass about creating interactive experiences in Unity using code and not using code as well, which is really handy for a lot of first-time people who are getting involved in the game jam.
Hi, everybody. Thanks for bearing with us while we dealt with some technical difficulties. Nothing like trying to stream on a Wednesday morning. Anyone that's ever run a stream before knows that sometimes stuff just sets on fire. And here we are. My name's Thomas Winkley. I'm a technical marketing advocate on the Unity team, specifically on the education team here at Unity. And my whole goal in life is to help people learn to make cool real-time 3D experiences. So I'm glad you're here with us today. I'm going to dive right into the presentation and get things going so we can keep y'all happy and on track if that works for everybody. So first things first, let me just find the window I need to click over. Perfect. So I already kind of introduced myself, but we'll do a really fast reintroduction of who I am. So I am a technical marketing advocate. That's a really fancy title that basically means I am a Unity developer that likes to talk to people. And again, I'm on the education team, and our sole mission on the education team is making sure that students and learners of any kind, anywhere in the world, have access to resources to learn to create real-time 3D experiences. And we are a team that serves the globe. So there's a lot of us working at this, but only a couple of us on this community side. And I just want to add a note that I am insanely honored to be able to be presenting to the Safe in Our World crew. It's an organization I'm a big fan of. It's something that I was so excited to find out that Unity supported, and I'm glad that we get to support you all more.
Well, we're very grateful to have you, so thank you so much.
Oh, thanks. I'm hopefully you can do more of these. You just gotta send the email or the Discord message, and we'll make some time. Some random fun facts about me. I like to make games, which is probably pretty obvious. I like teaching, which kind of explains why I'm here. My favorite genre of games, if it's not RPGs, is definitely fighting games. I'm a huge Street Fighter junkie, play a lot of it, probably more than is healthy. And my favorite food, hands down, is and always will be pizza. When I travel for work, when I travel on vacation, I basically try to find whatever the local pizza is and consume it. So if you have recommendations, throw them in the chat, send them to me on Twitter, wherever you prefer to share that kind of information, because I'm always looking for good eats. We've got all the operational stuff out of the way. I think it's time to build stuff. So the first thing I'm going to do doesn't have instructions, but it is important to create a new Unity project. So this is the Unity Hub. You'll notice mine is full of a lot of projects. That's because I have to build a ton of projects. And so in doing so, I have these here. But yours might look a little different. Yours might be empty. And we're going to start by hitting new project here on the top right. And again, you want to check your version. The demo for this, I'm going to be using 2022.3. My very specific version is .28. I think the latest version of 2022.3 is like .40. Basically, we're using a long-term support version of the editor. This means that it's stable, we know everything in it works, and we're keeping it updated and secure. I believe long-term support versions of Unity get an update weekly or every 2 weeks, so they're very well put together. And the project we're going to use, or the starter, is going to be the Universal 3D Core. This is our universal render pipeline. I'm not going to dive into the specifics of render pipelines, but at a high level, this is the most universal pipeline you can use for rendering objects. So it will work on the most types of devices, whether it be lower end mobile to higher end mobile, all the way up to virtual reality. And really the only time you would want to use like the high definition render pipeline is if you were targeting like AAA super high fidelity graphics, in which case that's what the high definition render pipeline is intended for. I've got to name my project. I'm just going to call this SIOW Live, since that's what we're doing. I'm not going to connect to Unity Cloud because I don't need the services today. And we're going to hit create project. The exciting part about this is now my project is building. Let me see if I can find my status bar. Just move it on over into the screen. But I'm willing to bet most of you don't want to look at the status bar. So I am going to jump the deck ahead a little bit, and we're going to talk about some key terminology we're going to use today while we work through everything. So, first things first, let's talk about scenes. Inside of Unity and inside your project, you have scenes. They contain all of your game objects. These can be used to create like a main menu, individual levels, or really anything else you want to group together. The best way I can think of describing scenes is they are buckets that you can put information into. Generally, if you're playing a game and you run into a loading screen, as an example, I would say there's like a 90% chance that you're loading into another scene. So they're actually taking that level, grouping it into a scene, and then we're loading it together to put everything into context. You can group things differently as well, but most common use of scenes is to load them into, like load levels into different scene groups. Another thing I forgot to mention, if you have questions or thoughts, feel free to throw them in the chat. I will happily answer them live. I can read and talk at the same time. Although my reading is very bad, I can read a little bit, just enough to get your questions. The next thing I want to talk about is prefabs, and we're actually going to come back to this slide again later. But prefabs are prefabricated objects, and what that means is they are pre-configured, right? And they're game objects that have all of the components, properties, all the things you need, and then you can just really, really, really quickly reuse them across your project. In game dev, we like to do a lot of working smart, not hard, right? Creating big, in-depth worlds takes a lot of energy. And if you're going to use, let's say, a tree, and all of these trees have the same properties and the same ideas and usage, then we might as well make a prefab of the tree so that we can just drag and drop multiple trees or duplicate multiple trees instead of having to manually recreate every tree individually. Same thing with players, same thing with projectiles or weapons or all kinds of things. So you can make prefabs of them and then you can just reuse them. And we'll talk about how we build those out. And I don't believe this is the first time I've ever timed this, right? But the Unity editor actually loaded in the background while we were talking about this. So we're actually ready to move to the next thing. So first things first, I do also want to talk about importing assets because this is really important. You're going to be sharing assets across your projects and you'll want to be able to collaborate. Now, if you're not using something like GitHub or Unity version control, there's other ways you can share assets, and these are Unity packages. So the first thing we'll need to do is go to the link that was on stream earlier, and I'll actually grab it and drop it into chat for you all as well. Bloop, bloop. Also, how you doing? I see some people popping off in the chat. Good to see you. And I just downloaded this Unity package. So what this looks like, I actually just deleted. Y'all, I did the bravest thing today. I just opened my downloads folder, I selected all, and I deleted the whole thing. Look how clean my downloads folder is. It was very liberating. It was pretty exciting. So what I've downloaded now is this one object, which is this intro package, which is from that URL I just dropped in chat. And a Unity package basically can store any number of project files that you can just import right into the editor. Can't see the link in chat? That's weird. Let me try it again. Oh, I wonder if it's because I'm not like a mod, so I'm not allowed to post links.
Yeah, I think it's auto-botted you, unfortunately, but you can send it to me and I'll post it in chat.
That's fair. You know what? I'm okay being auto-modded. That means we're being safe. And that's fair. Links are censored. I mean, hey, listen. Not my rules to write here. All right. So what we're going to do is take this and import it. So there's two ways you can import a package. The first way is you can right-click inside your project window, which shows everything available inside of your project. If I right-click, I can go to Import Package, Custom Package, and then it's going to bring me into the Downloads folder, and you can see I have this package right here. The other thing I can do is I can actually just left-click and drag this in and drop it into the project window. And when I do that, it's going to bring up the import dialog. Apologies, I'm working through multiple screens, so I'm going to have to drag stuff over. The import dialog basically tells you everything you're importing and what its state is. And this is really important. 403 forbidden? No. You know what? I bet I know why. Hold on. Let me fix this really fast. SIOW dash. Let me just pull up this real fast. Share. Oh, yep, that's why. I have it restricted. That's my bad, y'all. All right. Go ahead and try again. You might have to refresh. So, if we go look right here, you see that this is everything we're importing. We're importing some FBX files, which is a file format that allows us to share between digital asset tools. Then we have materials, which is how we represent color and depth of objects. We have miscellaneous stuff, But notice there's this new identifier here on the right. That means that this object has never been in the project. And this is really important because you'll also notice that we have the sample scene right here as new, but we have a prototype and it's got a warning and a little like refresh button. This means that, hey, there is a scene called prototype 1 in this project, but this one's going to overwrite it or update some features on it. And then you'll notice some of these features here are not being allowed to import. There's no checkbox. That means that we already have them in the project or they don't relate to the project. And we're just saying, hey, you're not going to bring these in. And we do that so that your projects don't get big and bloated and overloaded. So done all this stuff here. We'll go ahead and hit import. It's going to import everything and we can save. Now we've imported it and you'll notice I have this course library folder. The last thing we need to do is just open the scene. So if I go to my scenes folders, you'll notice I have prototype 1 and sample scene. So I'm going to double click prototype 1 to load into the prototype 1 scene. And I'm actually going to delete my sample scene by selecting it and pushing delete. If you're on Mac, it's command delete because we don't need the sample scene anymore. We have a scene. Now going back here, we have our scene view. We'll let lighting bake real quick. The scene view is how we navigate and look around everything that's going to be in our scene. So all the objects we've placed in our scene should be visible here and selectable here. Notice right now it's super basic. We have a road, we have this beautiful kind of sky dome that we're living inside of, and we have this barrel. Now I want to show you some beautiful shortcuts that y'all can use in order to navigate the editor. But I'm going to leave this on screen really fast on how to import assets. And the reason I'm doing that is so that if you're watching this recording, you can pause with my face like this. And then you can actually read the steps and follow along if you would like to. But we'll leave this live for a second. And if anybody has any questions, I can answer them. We'll do like a 1-minute countdown. Also, I'm really glad I have coffee. Actually, while we're waiting, I have questions for our wonderful co-host.
Hello.
Have you done any game design, whether it be tabletop or digital or anything?
I have not. I'm learning so much.
Cool. All right, you're learning with it. That's great. I'm glad to hear that.
Absolutely, yeah. That's why I'm not running anything to do with this. I'm just the coordinator of getting all the experts to come and tell us all of their wisdom because I think it's important.
I appreciate it. I wouldn't put expert next to my name. I would say enthusiast is probably a safer term.
Well, yeah, that's to be fair. So Sky's just put in the chat that we are writing a tabletop campaign right now, but I don't really feel like I'm doing it. Like I'm just kind of throwing ideas out there and then seeing what sticks, and then Sky and our wonderful team are pulling them together into real things. So
that's called design. You're designing.
maybe, I don't know.
That's how
I feel
game
like
design works.
Listen, imposter syndrome's big on today. I'm like,
I get it. I fully understand that. And I would like to make a note to everybody that we're all going to feel that. And you just need to remind yourself that you belong here. Because I have to do that too. Okay. We've imported our assets. We've answered some questions. Someone did ask if this is going to be uploaded somewhere. I assume it is. And I would guess it's probably on the tubes of you. But I will again let our amazing host let us know that.
yes, all of our masterclasses will be uploaded to YouTube after they've gone live, so that nobody misses out on anything, and you can catch up in your own time. So please don't worry. You can also submit questions post masterclass in the Discord, and we will do our best to answer them.
Yes, and I will join that Discord to make sure I'm in there, so you can tag me and ask questions as well. Okay, so we've talked about prefabs. Now I want to share this nice little cheat sheet that our amazing Learn team that I work with made for us, and it's just a quick cheat sheet that shows you how to move around inside the editor. So first of all, it talks about some really important pieces of navigation, which is this toolbar right here. So we have our hands tool, which lets us kind of move around like this, just drag and drop left and right and up and down. If you ever use like Photoshop or any like photo editing tool, you might be familiar with this. The shortcut for that is actually Q. If I hit W with an object selected, that gives me the move tool, which allows me to move the object in 3D space along these axes. And you'll notice that all these objects have 3 axes, right? We move X, Y, and Z. If you're on the other side of the ocean, it's Z. And the way we think about orientation in Unity is that X is left and right, Z is forward and back, and Y is up and down. That's kind of how we think about those orientations. So when you move something in the Y-axis, you should theoretically be moving it up and down at the basic level. Then we have rotate, which is E. Rotate lets you rotate the object around those axes we talked about, so we can just move this barrel like so. Then we have the scale tool, which lets us make it bigger and badder. So we'll make a giant barrel, sure, why not? Then we have the rect transform, which is only for 2D stuff, moving rectangles. And then we have the everything tool. This is the brave person tool. I've been using the editor for 7+ years, and I have never used this tool. This tool lets you move, rotate, and scale all together, and all the tools are there at once. It's not for me. I'm afraid of it. I don't use it. The other thing you should think about is moving around your scene. So if you want to highlight something, you can double-click in the hierarchy window, and it'll frame it. The hierarchy window shows you everything that's available in your scene. So notice we have the scene, and then everything is nested under here. If I double-click the barrel, it frames it up. Or if I'm zoomed way out, I can also select the barrel, hover my mouse in the scene view, and tap F. Oops, maybe not when I'm trying to rename it. And it will frame up that object so I can get to it. And this, when there's only one barrel in the scene, you're like, oh, that's not really helpful. But when you start building your scenes out with more complexity and layers, and there's thousands of objects, it's really nice to be able to double click on something and just frame it up and make quick changes to it. So, you know, navigating stuff can be really useful. The other thing you can do is if you hold right click, you can actually use the WASD keys to fly around inside the Unity editor like you're playing a first-person game if you want to move that way. And then I think you can use Q to go down and E to go up as well. So if you prefer to navigate that way, you can do that too. And then, of course, you can use our snapping, and your middle scroll wheel will zoom you in and out. All right, we've talked about navigation. We've talked about prefabs. Let's actually use some prefabs. So the first thing we're going to do is actually put a vehicle onto the road. Makes sense. We're making a car driving game. And this wouldn't be a fun course if we didn't provide some really cool prefabs for you. So we did. So we'll go into our course library folder here, jump into vehicles, and we have all of these different vehicles to try. I usually do this little Ute Red pickup truck, but I think today we're going with the bus. So I'll just left click the bus and drag it into the scene view. The other thing you can do is left click and drag it right into the hierarchy, and it will snap it to a predetermined point. But again, if you want to add it just into anywhere in the scene, you can just drag it into the scene and place it where you would like it. So I'll just drag it to like here. That looks pretty good. And then, like I said, I'll hover and hit F, which will let me frame it up. And then I can also alt left click to orbit around it and take a look at it and make sure it's on the road. Looks like it's touching the road, so we're good. Cool. Now we want to put some obstacles in because, in my opinion, the best part about video games is smashing stuff. So we need some obstacles to drive through. So we'll use some other prefabs. We'll go into our obstacles folder, and you've got crates and barrels. There's props here. You've got these nice little construction cones. We've got rocks. I think for this one, I'm going to middle click and drag over. I'm going to use the barriers. So I'll just left click and drag like 2 or 3 barriers in. Maybe I'll put like a barrier here and a barrier here. The other thing you can do if you want to just duplicate, you can hit Controller, Command D, Control for Windows, Command for Mac. And you can duplicate it, and then you can hit W to grab your move tool. And you can move your duplicated object around in the scene. So now we've got like these barriers that are saying you can't go anywhere. So that is the first set. I'm going to leave these instructions up really quick. You're going to want to add a vehicle prefab. And then in the same way, you're going to want to navigate to the course library obstacles folder. You're going to drag obstacles in the scene in front of the vehicle you placed. Then you're going to duplicate or drag more prefab obstacles into the scene. And then we're going to show you the power of prefabs and why they're so cool here in a second. And of course, chat, let me know how you're doing, how you're feeling.
Feel free to just repost that link. You now have moderator privileges.
Ooh.
So
Oh, that's right. I'm sorry. I totally
post
forgot.
Your links.
I forgot. And I was like, oh, yeah, I need to do that. Also, I feel like
we'll also put all of these links in the description of the YouTube channel for those not watching live. So please don't worry about that.
I'm also going to do something really fast while I'm watching. I'm signed in. Where's the button? Yeah, there it is. Cool. Just want to make sure I'm following so I can come hang out when there's other streams. Okay. Got this done. We're going to jump to the next piece, which is now adding components. So the way Unity likes to think about things, the way we like to think about things is we have objects, game objects, which is the base of everything we do, and game objects have components. So let's take a look at kind of what that means. I'll pull up the editor for you. So all of these things right here, the vehicle, these prop barriers, they're all game objects. And game objects all have one thing in common, and it's this component called a transform. Transforms are super important because it tells us three things. Where am I? Which way am I facing? And how big am I, right? Position, rotation, and scale. And we need to know that in 3D space so that we can place things in the world. So every game object is going to have a transform. That is their base component. But then they'll have a whole bunch of other components, which you can see in the inspector window when you select an object. We have this inspector right here. So we have a mesh renderer as an example, which tells the camera and the rendering system what this looks like. So this is what's telling it, hey, I've got these angled red stripies, I'm in the shape of a barrier. That's actually how that happens, is through the mesh renderer and the mesh filter. Then we have a collider. A collider stops movement, right? So if you've ever played a game where a person like walks halfway through a wall, or maybe their hand sticks through a wall, but the rest of their body doesn't, that's a collision issue. Colliders actually define volumes and say, hey, this is where you can go, and this is where your collider can go. So what I want to do is demonstrate something that's happening right now with our objects, and I'll lift two of these up, and I'm going to select our main camera and hit Control-Shift-F just to frame up the camera view so we can see these objects. And hitting the play button here will take our game into play mode, which means we can actually see what our end user is going to experience. And you'll notice that nothing is moving, even though these barriers are floating in the actual sky right now. They're not acting realistically, right? I think it kind of goes without saying that if I was to stick a barrier out off the roof of my house, it would fall to the ground, but that's not happening. The reason that's not happening is there's no component on this to tell our physics system that this object exists and needs to be processed. So we'll actually select this barrier right here. And in the inspector, I'm going to scroll down and click on Add Component. And I'm going to search for rigid, and that will bring up rigid body. A rigid body is an object that basically tells our physics system if gravity is applicable. It also can determine the velocity of the object. It lets it know to simulate it. It's really how our physics system knows to interact with this. And now that this has a rigid body, it should fall to the ground. So we can go test that really quick. I'm going to go to the game view, maybe just give myself a little more screen space, and hit play. Okay, so it fell. But notice only one object fell. And this is where prefabs are so powerful. So in your head, you're probably thinking, all right, well, now I need to go to every single one of these prop barriers that Tom added, and I need to add a rigid body individually, right? But because this is a prefab, that means there's essentially a saved template of how this object is configured inside of Unity. And what we can do is go to this overrides button right here, and you'll notice it shows us that a rigid body was added, and we can simply hit apply all. You saw this refresh. That means every single prop inside of here now has a rigid body, and we didn't even have to add it. Well, that's the vehicle. The vehicle doesn't have one, but there you go. Prop 1, Prop 2, Prop 3, Prop 4, all of them have a rigid body now, and we didn't have to add it. So if we were to grab, let's say, this buddy, and we'll grab this buddy, whoop, and hit play, they're all going to fall to the ground. So again, work smart, not hard. That's what makes prefabs so powerful, is you can apply that template and say just like, all right, well, I've decided to modify this a little bit. I'm going to give everything a rigid body. Give everybody that thing. Cool? Cool. We've covered the basics of prefabs and adding components. I am going to leave these steps up here. So you're going to select an obstacle in your hierarchy window. Then in the inspector, you're going to add component and search for the rigid body. And then on top of the inspector, you're going to click overrides, drop down, and select apply all, so that it applies to all of your objects. And now all of those obstacles, specific instances, will have that. Now, if you use different types of obstacles, for example, if you used a barrier and a barrel, you're going to have to add a rigid body to the barrel and do the same process, because the barrel is not linked to the barrier, but the barrier and all versions of the barrier will update automatically. Cool. If you're watching the recording, great time to pause, look at the instructions, catch up. I'll try to do a good pause face like this. Okay, great. All right, y'all. It's time to do some code without writing code. I'm going to preface this with something I believe. If you are creating interactions using Unity visual scripting or text-based code, you're developing code. I don't think either way matters. They're both optimal. They both work really, really well. And they are both tools for creating powerful stuff. And I believe we here at Unity believe this as well. This is why we have visual scripting. Visual scripting is a node-based system that allows you to create interactions and is a very common thing in the industry. It's used in a ton of tools like VFX tools. I know it's in Maya, Blender. Some of our competitors have it as well. We use it too. It's a great way to visualize logic and build things out. And so let's create something that we need to have happen pretty commonly, but we're going to use visual scripting to do it. Okay. Jumping back to the editor here, we need to create a camera follow. So this is our main camera, and you notice I kind of like have manually moved it around to frame up what the scene is going to look like. But we actually want the camera to follow the car. It would be really weird if the car just drove off and the camera stayed in the same place and we couldn't really see where the car was. So we need to create a camera follow. First thing we're going to want to do is make sure our project is nicely organized. So we're going to go to the assets folder, right click, go to create and folder, and we'll name this new folder visual scripts, because that's where they're going to live. Then we'll double click into it to make sure we have access into the folder. And one more time, I'll right click inside this folder. I'll go to create, visual scripting, script graph. And we'll name this camera follow. So a script graph is essentially the set of instructions that we will apply to a script machine that will run the graph. Let me pop up this really quick and leave these instructions on screen for those following along. If you're following along in chat, just like let me know. Maybe type like a 1 or a thumbs up or a gibberish word or regular word, whatever you want to do. But we'll leave this here for a second. And if you have questions, of course, feel free to pop them in chat and we'll answer them at any given moment. The worst part about saying I like pizza in all these presentations is I spend the next 45 minutes thinking about eating pizza.
I know, honestly, ever since you said it, all I want is pizza.
Yeah. It's like a blessing and a curse, because like the likelihood of me getting pizza just got way higher. But also,
yeah, I have one in the freezer. Uh-oh.
You're blessed. Blessed are those who have pizza in the freezer. All right. I'm assuming everybody's caught up, so we're going to jump to the next bit here. So we've created our visual script, and now what we actually want to do is make that visual script do visual script stuff. So jumping back to the Unity editor, I am going to hit Control-S really quick to save. I'll select the main camera, because really the main camera is the object that's going to be following. And we are going to need to utilize that to work through some of these. So on the main camera, I'm going to scroll down in the inspector and go to this add component option, the same object that we used to do our rigid body, but I'm going to search for visual. Actually, I don't think it's visual. I think it's just script. Yeah, script machine. So this is what runs a visual script. So we'll add a script machine, and it has a reliance here. Notice it also added this variables component, and variables are where we store information. So the script machine is going to help us do that. Making sure I'm doing everything correctly. Yes. So right now our script machine, notice it has this graph field, and it's not telling us exactly where what graph it wants to run. So if I click this little node here, this little circle dot pointer, I can in my assets find the camera follow, and I can double click that, and it's going to assign it right in here. So now we actually have access to it. The other thing we do need to do is add some variables. So on the variables component, I'm going to click on new variable name, and we'll add a variable called follow object. Actually, no, we'll call it follow transform. We're going to be very specific. And when I hit plus, you're going to see some code compilation happen. And then it's going to actually make the object, but it's going to give me some data I need to fill in. So we'll just wait a second while this initial node generation happens. Make sure to hydrate everybody. Luckily, it's not quite, it's a little early where I am, so the heat hasn't quite spun up yet, so it's still, relatively cool. Okay, this is done, and it's made our variable with the name, and it has this type field, so it needs to know what type of variable is. Is it an integer? Is it a vector 3? Like, what is it? And we're actually going to say, hey, this is a transform. So we'll search for transform. Whoop. Oh, it popped it off my screen. Can I move you back over here? I cannot. Okay. Well, I'll change it to transform. You can't see the search list. But remember, we talked about this earlier. Every game object has a transform. So we're basically creating this variable that's a reference to a transform so that we can manipulate the position, rotation, and scale of something should we need to through code. Now we'll make one more variable. We're going to call it offset. This is how far back the camera is going to sit from the object. And when I hit plus, it's going to ask for a type. And this time we're going to use a type of vector 3. And a vector 3 stores an x, y, and z float value. If you're a physicist, this is very common in physics, but it's super useful in 3D space because it has the 3 coordinates we need. This isn't in the instructions, but I'm going to call this camera follow in the script's name. And the summary, I'm going to say follows a selected transform, but hangs back at a selected offset distance, just so we know what it does. Okay, so we've set these up. Let's pop onto our instructions so that y'all actually have that to look at. And if you're following along the recording, another good moment for you to pause. I'm out of coffee. Oh no. So quick review. You're going to select the main camera. In the inspector, you're going to add a component and search for script machine. You'll click on that small circle next to graph in the script machine and assign our new graph that we made. Then in the variables component, we're going to name a component follow transform. Click plus, set the type to transform. And then we're going to do that same step, but we're going to make a variable called offset, and we're going to set it to a type of vector 3. I'm just checking the time to make sure we're not going too ham over here. So look at what OBS says, how long we've been live. Okay, good. We've only been live for half an hour. We're good. All right. Back in the editor, let's actually edit our graph now. So from the script machine, I'm going to hit edit graph, and it's going to pop up our graph editor. Let me full screen this. So this is now our script graph that we are going to mess with and change to create interactions. So first things first is we need to have access to these objects to do something with them. And so these are our data inputs, or our these are our variables, essentially, our data inputs. And we have them at graph level, object level, scene level. I'm not going to dive too deeply, but object level essentially means it exists on the camera, at the camera level, and we'll have access to those. And when I select that, notice we have that follow transform we created, and we have that offset we created. And I can just left click and drag them onto the blackboard here. And now I have a reference node to these objects right here. Cool. The next thing I need to do is create a node. So we mentioned that transforms contain 3 things: position, rotation, and scale. And what we're trying to do is set the camera to the position of the follow object. So I can click on this output right here, left click and drag and release, and that'll give me an editor window to bring a new node in. And I can actually search for transform get. And if I scroll down here a little bit, I'll see get position. So what is happening here is this is now saying, okay, you have a transform, let me get that position value. Now from here, we actually need to add the offset together. So from the offset, I'll left click and drag out, and we're going to search for an add node. So we now have an add node that'll add A to B. So this is being treated as A, and then we'll drag our position to B, and we are now combining these 2 inputs. Now, the final thing we'll need to do to get this graph built is we need to set a position. So we got the position, we added it to the offset, and now we need to go to the transform and set the position. So what I can do is left click here again, drag out. We'll search for transform set POS, and there's transform set position right there. And you'll notice that it is actually taking it to this transform node. So because I used a generic transform, it just gave us a generic value. So I can right click to disassociate this, and then I'm going to left click and put this into this value because this will be the position value. And the reason I'm doing this, let me kind of zoom some of these over a bit to give some more visibility here, is, can I use minus to zoom out? No. Okay. Bloop, bloop. Is we have this. So what this means is whatever this script is attached to. So what we're saying is set the position of this object to this value, which is the position of our follow object plus our offset, blah. So that's how we're setting these nodes up. And that is how we set up the first bit of this interaction. So let's get those steps up on screen so y'all can follow along. Bloop. And I realize it's a lot of steps. I apologize. I'm trying to make this in a timely manner. So, sometimes we have to push some steps onto the screen. But essentially, on the script machine, you'll edit the graph, drag both object variables in. Then you're going to output from the transform node and make a transform get position. Then you're going to make a transform set position node and add the 2 together to combine into it. Then you're going to connect your variable output into the slots, and then you'll drag from that and do a set position. It's a lot of steps, I know. Also, I think I just caught a typo. My apologies. Okay. I'm going to bump ahead just so we stay on time. So the last thing we need to figure out is, when is this going to happen and to what? So right now, this code is all here, but there's never a time that this happens. And in this instance, we actually want to follow this every single frame, right? Because if the character is moving, it's going to be moving every frame so that the inputs feel good. That means the camera probably needs to update its position every frame to make sure it looks good. So what we can do is right click up here, and we're going to add a node, and I'm going to search for update. And when I search for update, I get two events. I get on update and on late update. Now, update fires every single frame, which in a game is 60 frames a second, which means 60 times in a second, it's going to check and update the transform position, which is awesome. Now, with a camera follow, I want the last thing that happens in the frame to be the camera updating. So we're going to choose late update. The only difference is this fires after all the update loops are done. So I'll choose this, and we get this event node. And you'll notice it's nice and green and with an arrow heading to the right. And then we have an input arrow here on the transform set position. So what we can do is left click and drag this over here. And this is basically saying now every single update frame at the end of it, it's going to pull this data and apply it here. So this is basically our script graph, and it should execute just fine. I'm going to save this just to make sure. Oops. I accidentally duplicated the node, my bad. I'm going to close the graph, and we need to set a few things. Notice that this variable value says none and none. So we need to, first of all, pick the object we want to follow. We're going to pick our vehicle bus. So I'll left click the vehicle and drag it into this inspector here. And then in the offset, I'm going to have the X offset be 0 because we want the camera centered. The Y offset is going to be 5. It's going to be a little bit above. And the Z offset is going to be minus 10. So it's going to stay 10 meters behind. Then on the camera, I'm going to do one more thing. I'm going to make sure that the X rotation is 30, 0 and 0 on the Y and the Z. And then the rest of this actually does not need to be changed because the script will automatically set everything for us. So theoretically, if I have not completely messed this up live, I'll put our game view over here so we can see it. And let's hit play. Okay, so notice the camera automatically snapped behind the bus. Everything fell. Now we don't have a way to move the bus with controls, so I'm actually just going to select the bus in the scene view, and we'll just drag it. And notice that the camera stays snapped to the bus, which is exactly the behavior we wanted. Okay. So our camera follow is working as expected, and we didn't write any text-based code. We just used visual scripting. Huge fan of visual scripting. Love it, as you can probably tell. But now let's actually dive in and let's do some text-based coding to create some vehicle and movement. So actually make the car move. Whew, hope you're all ready. So first things first, go to the assets folder. We're going to right click, create a folder, and we're going to call this scripts. Again, the reason why I'm having you watch me create these folders live is project organization early on is going to save you a lot of frustration later. As your project scales and gets bigger, if you have a nice set of naming conventions and good organizational conventions, when you've got 5,000 things in your scene, it'll be way easier to figure out what you're doing. The complexity will be fixed and a lot better. Okay, sorry, I just had to not die, take a breather. Okay, I'm going to fix this by just snapping back over here. We'll kind of scoot the inspector over. And inside my scripts folder, I'm going to right click. I'm going to create C# script, and we're going to call this vehicle controller. And once that's made, I'm going to double click to open the script and let Visual Studio load. While that's loading, let's take a look at using C#. So I want to talk about a couple things in C# for those that may not be software developers. And what those are is this stuff right here. So there's a couple things that make the shape or the frame of a frame, the shape or like the components that make up a C# script. So you've got, first of all, the public class camera follow. This is your class declaration. So this tells us what the name of our object or our class is. This also tells us what the mono behavior type stuff is, what it extends, which is mono behavior, which gives us access to all of our Unity properties we want. Okay. Then we have our variables. So just like we made the variables in the visual script, these are the variables we're declaring here. So we have a vector3 called offset and a game object called follow object. Notice I'm demonstrating the script, the text-based version of the visual script. Then we have methods and functions that actually make things happen. So this is our function to update the camera position if we were to write it with text. You know, we're basically saying, hey, the position of this transform needs to be the follow object position plus the offset, and then it will follow. Okay? So again, just to reiterate the anatomy of a script, class declaration, variables, and methods and functions. That's really what makes up most of a script. So we already went through creating a script. Let me just show you the instructions for this really quick, and we'll give this just a second. So you can create an open folder called scripts. You'll right-click on the project window, create C# script. You'll name it vehicle control. Then you'll left-click and drag your new script onto your vehicle in the hierarchy, and you'll double-click and open the script in Visual Studio. I have not added the script yet, but I'll do that when we get to this next part. Checking our stream time right now. Okay. We're going to try to make the rest of this happen in like 10 minutes so that we have time for Q&A if there is any. All right. Going back to the editor. Let the domain reload because it needs to compile my new set of code I put in. Drag this over. And to add this to it, I'm going to left-click and just drag onto the vehicle like that. And by doing that, when I select the vehicle, now in the inspector, you'll see down here, we have a vehicle controller script right there. I already have this open in Visual Studio, so let me just get Visual Studio pulled on over. Perfect. So this is here. Let me just clean up. We'll get rid of that so you can see better. And maybe as a control, yeah, we'll just zoom the script in to make it a little bit bigger. So this is our base controller. Notice Unity generates some boilerplate. So we have our vehicle controller that extends mono behavior, and we have access to a start function, which is the first frame update calls it only once. And then we have update, which happens every frame. So we already have this. And the first thing we'll need to do is declare our variables. Now, if there's any seasoned developers watching, I'm going to use public variables for simplicity for the first part. Yes, I totally understand this doesn't follow solid principles, but we're teaching stuff. It's time to go a little easy. So first, we got to say how accessible this is. We're going to see public. I mean, anybody can get to it, right? This is like a public park. Anybody walks in, they can hang out in the park. And we'll call this, it's a float is the type, so this means it's a floating decimal. And we'll call this move speed. We also need to declare a public float rotate speed because we want to be able to rotate the car as well. So those are our two variables. The first thing we definitely want to do with this is start by just making the vehicle move. So again, I mentioned we want something to move every frame, right? Which is where we can use update. Now, update's really, really good for this type of code, especially if you're getting like input stuff. It is not good for code if you need to like search for a lot of stuff and do really complex calculations, because every object has an update method. And if you're using the update method to do big calculations and you have 500 objects, that means every frame that update function is processing 500 times, 60 times a second. So at scale, it gets really dangerous. But for input stuff for a character, it's really, really good. So what we'll do is we'll simply say transform.translate. We need to tell it where to translate it. So we're going to use a shortcut called transform.forward. This essentially means what the forward direction of the car, which is the z-axis. Then we'll say times that move speed that we declared. And then we're going to ease it. And actually, I'm not going to ease it first because I want to show you all something kind of wild. So right now, we're just going to say every frame, move this at the move speed. Yeah, we got plenty of time. We're going to be fine. So let me check one really fast thing. You know what? No. Let me just check my calendar to make sure I'm not too late for a meeting. Nah, I can be late for this meeting. It's fine. Okay, so we'll go back to game view. We're going to hit play. And we're going to watch the values on the car. Now, you're first off going to notice that nothing happens. It's because we never set the speed of this. Let's just set the move speed to 5. Look how fast our car is moving in the Z direction. It is way off the road. It is gone. The reason for that is it is moving it 5 units a frame, which means every frame it's moving it essentially 5 meters. So you can imagine why that did not react the way we thought it should. What we can do to fix that is we can smooth this, and we're going to multiply it by a time.delta time. This is a nice Unity shortcut or utility we have that basically tells you how long it takes to process a frame. So that way, it's not moving 5 meters per frame. it's going to move 5 meters per second because it's going to multiply it by a small decimal. And now when we do this, our car should move smoothly. So 5 and 0, go ahead and hit play. And now it moves at like a pretty reasonable pace. It's still kind of a slow moving bus, but when we turn that speed up a little bit, maybe we bump it to like 10, it moves faster, but it's not flying off the screen and breaking, which is pretty cool. Okay. All right. Let's move into actually getting user input. And we're going to move a little bit quicker so we don't run out of time. But what we need to do now is actually get access to the input system. And Unity has an input system that uses axes that tell us like if you've pushed W, A, S, or D. And so we can use those by using string values to figure that out. So we'll jump in forward real quick and back inside vehicle controller. We are going to add 2 new variables. We're going to have a private, which means no only people that can access it are people that own it, which would be the vehicle controller. And it's going to be called, we'll call this move forward. And then we're going to have, I didn't give it a type though, so it's going to give me an error. So we got to do a float, move forward, and then we'll do private float xval. So this is the left and right value. And then inside of update, we need to get some information. So every frame, we need to check the value of our input system. So we're going to say x value equals input.getAxis horizontal. So the horizontal axis is assigned to the A and the D buttons. Basically, A is -1, D is +1. And so if D is pressed, we get a +1. If nothing's pressed, we get a 0. And if A is pressed, we get a -1, so we can move left and right. And then we want to also get access to move forward. And we want to set that to input.getAxis vertical. Okay. Now that that's set up here, we now have that value. All we have to do to make the car move forward and back is multiply this by the move forward value. Because if move forward is not being pressed, the value is 0, and anything times 0 is 0. But we can, otherwise, it's going to move forward at 1 times all of this. Now, the last thing we need to do is actually rotate this. I'm going to zoom out just a little bit. So we're also going to say transform.rotate. We need to tell it which axis to rotate around. So we can actually say transform.up, right? So around the vertical axis of our object, so it rotates left to right. And then how much do we want to rotate it by? And we can actually rotate it by our rotate speed times time.delta time times xval, which is the amount of the press, right? And then we can manipulate the speed to make it feel nice and smooth. So realistically, we should have access to all of this stuff, and we don't need the start function to get anything, access to anything. And this should move our object as we want. So let's test it real quick. Oh, we're so close. So we look at our vehicle. Let's go down here and make sure we set our rotate speed to 20. I actually like the move speed of 10. That felt better. And then let's actually change this to play maximized so that when we hit play, we'll see the whole window. And if I hit forward and left and right, I am now using WASD to move around. And if I take my hands off the keyboard, car stops. So that's kind of the basic input. And notice that we didn't have to code anything on this portion, but because of collisions and rigid bodies, we can drive through and crash through these objects and make weird stuff happen. Now, we are using physics and translation together, which a little bit weird, so there might be some collision stuff. So generally, you'd want to use physics and everything, but for this demo, it's really fun to just kind of move around. And if we drive off, because the car does not have a rigid body, know that our car can drive forever and never die, which is kind of wild. So we need a rigid body to fix that, but that's okay. All right, gang. I'm sorry for speed running that last little bit, but I definitely wanted to make sure we had time to get to the end of this demo. So when you test it, you're going to hit play. If there's any weird smoothness issues, you can change this here, but notice we used late update, so it worked fine. And just going through all of this, you've already made like a small game, right? A miniature game on the infinite vehicle that can drive anywhere. It's time for the Thomas Winkley shill session. If you want to learn more about this, you should absolutely go to Unity Learn. Unity Learn is amazing. It is one of my favorite websites of all time that my team works on, and we build content to teach you how to make games in Unity. And what I just did was actually a demo from one of the courses called Create with Code, which is the first part of the junior programmer pathway. Now, full disclosure, the junior programmer does not talk about visual scripting. It is all C# based, but that is the code right there you can tackle. And if you want to dive more into visual scripting, we actually have we have two really cool courses on visual scripting. One is an introduction to visual scripting right here. And then we also have one, which is my favorite because it's a pun. It's called Clive the Cat Visual Scripting. But you actually build like a little cat crawler game using all visual scripting to set it up. Learn is completely free. There's a ton of amazing content available for you, so you should definitely check it out if you want to learn more. There's like 3,400 plus tutorials, like 1,400 hours of content. We have pathways. And then if you're an educator watching this, we have a whole hub to support educators on teaching this in the classroom. We also provide free licenses to students and educators. If you go to this bit.ly link right there, you can get access to that for free. And thanks, y'all. That's the demo. If you want to look at Unity resources, you can scan this beautiful QR on the left. If you want to connect with me on the social medias, whether it be LinkedIn or Twitter or X or whatever it's called now, you can hit there. And I'm happy to hang out if there's any questions from anybody before we sign off.
That was amazing. I loved it. Thank you so much.
No problem.
It's so interesting. Like I've never really watched anything like a demo of like basic gameplay being started. So it's yeah, it's awesome to see. We do have a question in chat that I've just
Ooh, I like this
come through that
question.
says, can you recommend some learning steps on code organization, useful patterns, etc., ways of keeping data like game level settings, solving communication between different parts of game, like do lots of visual changes on time change, for example, day-night cycle. I tend to have logic spread to different scripts or spaghetti code.
Totally. So it's all going to come down to organization, and I really recommend you start looking into design patterns because design patterns are built to solve this issue, right? Unity actually just released a free ebook all about design patterns. Let me just find it really quick. Yeah, right here. This is the post I would recommend looking at. But what you're talking about is like you need the implementation of solid design principles and design patterns in your stuff. Because that's what's happening. You're like, oh, I just need something to do this. You're writing it over here. You're slapping it on, and then you're linking things to other things, which is totally fine. But like as an example, if you're updating a UI, instead of writing a thing to make sure the UI updates every frame, you could use like a listener pattern where essentially an event fires when the UI needs to update, and then when that happens, they're just listening for the update information and then they update, right? Or a singleton pattern to control all of your game manager logic. So that's the type of stuff you want to learn about is start looking into design patterns. And really my best recommendation is to practice building stuff with those design patterns. And you'll start to learn like which design patterns you think are better for building different things. And it's just a really good way to practice. The way I do it, I generally, and it's really dorky, but it's fun. If I'm playing a game and there's a mechanic in the game I really dig, I try to recreate it in Unity and try to figure out like how did this game mechanic come to be. And that's how I keep myself motivated to learn. But yeah, that's what I would really recommend for what you're running into. Because yeah, you definitely want to start looking at like design patterns and how you're going to be connecting everything together. And that ebook is free. And then we also have a learn course on design patterns as well. But that ebook is really helpful. And those are applicable just outside of game dev as well, right? Like design patterns are universal, so they're applicable to local application development, any kind of general software development, web development. It's not just a game dev thing. Software dev principles are software dev principles for a reason. Yeah, any other questions?
Can't see any more at the moment.
Cool.
But someone has said it was a very cool demo, and you're so brave to show all of it live.
Yeah, no worries. That's what Unity likes me to do. If you want to see more bravery, we'll be live on Twitch next Tuesday. We're building a multiplayer game on twitch.tv/Unity. So if you want to see some real scary stuff, that's where the real fear happens. Thank you all so much for hanging out. It was fun.
Thank you so much. That was so informative and really I just think you're a brilliant host. So thank you for
Thanks.
making that fun to watch as well. I really appreciate it. And yeah, thank you everyone for showing up. This will go live likely tomorrow on YouTube. I will put all of the links mentioned in the chat in the YouTube video description as well, so you can get them. They're also now in a resources tab on our Discord at discord.gg/safertogether, which is on the screen. So feel free to hop in there if you haven't already. Other than that, thank you so much for your time, Thomas. I really, really appreciate it, and I know that it's been really helpful for a lot of people watching as well. So thank you. And yeah, I'll keep you all up to date on the next masterclass, which should be in September, which will be about QA. So please stay tuned for that. Very exciting stuff. But yeah, I think other than that, I'll let you get back to your day job and not miss the meeting that you're definitely late for.
That's okay. They don't need me. It'll be fine. Thank you all so much. Have a wonderful rest of the day. Really appreciate you putting this together, and we'll talk to you all again soon.
Awesome. Bye, everyone.